Hello everyone, and now further I will talk about the materials, as material is one of the important components in all the electronic products, and the sustainability of materials is also defining sustainability of overall product. From the scheme you see that electronic product or electrical product consists of a lot of different components. You have the single components which are making the conductive path and which are making the functional properties of the material. You assemble them all into PCB, and then finally you have all the different types of the products with the casings and all the other possible assemblies. So in each type of the component, quite often you have very complex materials, starting from metals, ceramics, different type of oxides, and plastics. This is one of the examples how much of different type of materials there is extracted from with a scrap. Numbers here might change depending on the type of scrap is collected. Here try to be the combined scrap, but depends very much on the country where is that scrap collected to, because quite often the big instruments and all the appliances from household are collected, while a lot of small appliances are being discharged outside the collection systems. So from this you can see the hint that the biggest amount of the metals used is copper, and then you have also iron, refractory oxides, this is ceramic oxides and also include the same metals, and then finally you have the big portion of plastics. So materials in electronics are used, as I just mentioned, for making PCB boards, where you have the metals, oxides, polymer substrates, also coatings on the top, but then also you have a lot of plastic components and then different casing components, metallic components for the final assemblies. In material choice, usually as minimum you have to comply with the REACH and ROX regulation, but if you want to look for the new sustainable materials and want to go to beyond, you should look for supply chain of the ethically and socially with the reduced impacts materials. Then you should look for the materials from the renewable sources, and at least materials which are produced using renewable energy for the recycled materials. And LCA is as a tool to evaluate the environmental social impact assessment through all the life cycle. So what kind of metal and metal oxides we have, and some hints which of those are superior comparing to each others. So as a sustainability challenges for metals, we have the depleting resources and not renewable resources. You know, we have a lot of social issues related to mining. Even in the developed countries, mining is not really what people want to be nearby. I know in Sweden, for example, at the moment there is reopening new mine where all the settlement needs to be moved to another place. Especially mines are in some remote areas. They can be endangering the cultural and natural environment of indigenous people. So usually social issues in mining is very big. Another issue is also environmental issue. For example, here as example given the mining of copper in Chile, it's using a lot of natural resources like water. Minings are also big operations, so you have a small amount of metals in the big amount of stone. Digging all the big area up and then reshaping it back, it changes totally the natural environment we have. Also, in the underdeveloped countries, we know a lot of social issues related to the salaries of the people. They are not getting salaries, The ones who are profiting from the mining usually are somewhere high in the political ranking, and they are not giving the money back to the society who has been actually working for the mining those resources. And one of the problems we all encounter is the amount of the materials we have in our land. So the precious metals, for example, the resources are really scarce and low. And if we are all the time only mining new resources, at the end point we don't have them enough, or prices are so high that we don't have sustainable products in the market, or we don't have products the buyer can afford. So what could be the more sustainable options is to use the recycled metals. Then some metals are superior comparing to others. Of course, you don't want to hinder your functional properties of the products, so you always have to evaluate possibility to exchange your raw materials to others depending on the product you have. Over design is also costing, so instead of, for example, having silver, maybe copper is the better option. Copper resources in the world are larger than silver, so you could exchange it. Copper is also cheaper, so try to evaluate if you really need silver and rather choose other metals. Furthermore, maybe even copper is too good material, or the properties of it is overestimated, and then you could use aluminium. Aluminium itself is very good material. It's lightweight. It has very good recyclability. It also retains properties during many recycling processes. One of the new materials entering the market, and there are a lot of studies already done on conductive carbon. Conductive carbon, graphene for example, can be produced also from bio-based sources. I will show that a little bit later. So because organic carbon we have anywhere in the organic materials in our nature, and all the waste, for example, is possible to be converted into carbon products, and then those carbons functionalized to be conductive or to made into graphene. The big part is also plastics, and plastics have very good properties. They are used very wide in electronics in the different positions for the casings, of course, but they can use as a separator, films, different coatings and so on. So they have the good electrical insulation. They usually are heat insulators. They are lightweight comparing to metals. Then we have a lot of different methods and production methods developed, so we can have freedom in design, and especially the new 3D printing methods, for example, opening totally new design possibilities for the final products. And they are also durable. Plastics, there are of two types. They are thermoplastics and thermosets. Here in table are presented the differences between them. So looking from the raw material perspective, or the ones you are sourcing in, usually thermoplastics are granules, and then thermosets usually are liquids. They are actually, after mixing few different components together, forming only during the processing the solid material. So then in the process the thermoplastic material is melted, and then after melted is formed into shape we want using the different molds. Molds usually are expensive, which is one of the drawbacks of plastics. But then again, those plastics are used for the mass production, where you can produce a lot of same type of product, and especially for the electronics components, where you have a lot of the similar components. It's the very good and fast method to get the plastic part we need. While thermostatic resins, they are usually hardened as a chemical reaction. They can be hardened with the heat or with UV lights. There are also some other methods. But the main advantage of them is that when the temperature is raised up, after they already once solidified, they only soften, but they don't melt, while the thermoplastic materials melt. On the other hand, if we are looking to the recyclability, thermoplastics are easy to recycle. You can grind the material and then use the same tools you used before through the melting to reshape them into new products. While thermostatic resins are not recyclable, You can grind them and use as a filler, but they don't have value. So the only recycling method would be expensive chemical recycling, where you are actually destroying the chemical structure and then making new polymers. So from the eco-design perspective, choosing thermoplastic over thermoset would be better options. However, thermoset resins usually have much lower thermal expansion, which is very important in, for example, PCB boards, because you are using the metals which to remelt needs to have high temperature process, and the thermoplastic polymers cannot withstand that. So looking into use, thermoplastic polymers are mostly ABS, PP and PS. They form about 70% of all the plastics used in the electronics and electrics industry. We have also PVC. PVC, I need to mark that it's actually very difficult to recycle, or this is the material which has chlor inside. PVC is polyvinyl chloride, which during melting can start decompose, and during decomposition hydrochloric acid is formed. So it means that your processing instruments can be starting to corrode, and then recycling of PVC is not really what any recycler wants to do. But we have PVC a lot in our wiring. Most of the copper wires or most of the electrical cables, PVC is the one which is covering them. For thermoset composites are usually used. That means that we are reinforcing the thermoset resin additionally with, for example, glass fiber, so that we further enhance the thermal stability and we reduce the thermal expansion. And those composite materials with epoxy usually are used for PCB substrates. So looking into the landscape of the bio-based plastics in the market at the moment, in this scheme you see that we have the materials which are recyclable, which are made from the fossil-based sources. They are the ones I was just mentioning: polyolefins, polyamides, ABS and so on. Then we have the counter polymers made from the bio-based sources. So you can do the same polyethylene type polymer using the sugar and using the different sources from the nature. They will have about the same properties. So if you didn't have the biodegradability in your polyethylene, which was produced from fossil-based source, you will not have that also in the bio-based option. Another option is to produce using the bio-based sources the product which is biodegradable. And for example, the very common polymer which we have now in the market already, it says PLA. This is the polylactic acid, which is produced from sugarcane, from sugar beet, from maize, or can be produced even from grass. This is one of the most available at the moment materials, but there are also new materials emerging. And if you want to look closer to what is in the market, you can look into Nova Institute. They have very good market analysis. Biodegradable plastics actually can be done also using fossil-based sources, and there is one material in the market on this. However, those bio-based materials at the moment are so much wanted that it's very difficult to find the materials in the market. And if you have the very big production, then it's probably easier possible, but if production is low, might be that you really don't have access to material. For example, PET, which is used in the bottles. So this counterpart bio-based PET is fully sold for the bottle producers, because big companies like Coca-Cola, they want to be sustainable, and then they buy full production available in the markets at the moment. Bio-based content in polymers can be also increased using different natural additives. For example, natural fibers. This is one of the very common options at the moment, and this type of polymers are already possible to be found. So one of the advantages is that you can exchange up to 50% of the polymer which is produced from the synthetic sources with the natural resource. Usually natural fibers don't need to be treated very harshly in chemical wise. You can use, for example, wood flour, which can be even waste from the forest industry. You can use cellulose fibers, which is the product from the pulp and paper industry, cork, then also hemp, flax. There are also others, bamboos and whatever. They used in thermoplastic polymers quite often. Polymer after the addition is still recyclable, so you can still return it back to the same cycles. One of the additional features fibers have, and why fibers actually should be used, is to improve the mechanical performance. So the improved stiffness usually you get always when you are adding it to your thermoplastics. Advantage for thermoplastic is also that it reduces a lot of thermal expansion and shrinkage, so that with a good combination of polymer and fibers, you can also use the material for the PCBs in some cases. And advantages for thermoset composites, especially if you want to replace a glass fiber which is used in the composite, is that natural fibers have much lower density. So the end point is that you are getting much lower weight of the final product, and then you can calculate all the emissions related to the transport and use. Through the life cycle, you have the savings you would like to have in your sustainable products. Then also you can look for you need to look for the functional additives, because in some cases you need to functionalize your polymers to have certain properties you would need to have, like for example electrical conductivity or improved thermal conductivity. So, and as I previously mentioned, the graphene and carbon nanotubes and conductive carbon, they are possible to be obtained from the bio-based sources. So actually you could increase the bio-based content through having materials developed from those sources. Boron nitride could be also added to improve the thermal conductivity. It's inorganic material, so you don't have it as a bio version, of course. There are also a lot of different other components you would need to add. Maybe you want some different color, you want UV stability agents, and always looking for those additives, you should look for the bio-based versions as a first choice. So bioplastics in the market, you see the list, what it is now. As I just mentioned, the PLA is the most common material and the most used, and also you have the starch-based materials. PLA has a lot of the same properties what usual polyethylene, polypropylene polymers have, so the same equipment is used to make new products, and as the properties is quite similar, with some small adjustments you can easily replace, for example, casings. There are also a lot of materials already in the market with fiber reinforcements. So here is the list of, for example, Finnish UPM produced material, where we have the wood cellulose. There is Archema, who has different options. Stora Enso from Sweden has also wood fiber based polypropylene and other options. In some cases also the PLA can be reinforced with the polymers to give the same properties I mentioned before, especially to have the better thermal resistivity and then thermal shrinkage or expansion. And as I mentioned, if you want to see suppliers, you can go into Nova Institute pages. This is Biobased EU. It's website developed by them, and the database of the different producers in Europe at least. To have sustainable options of carbon, there are 3 different ways. We can have the carbon recovered from the recycled material. We can have carbon recovered through the CO2 collection from the exhaust pipes, for example, or from other places where CO2s are generated. And we also can have the bio-based resources directly from the different types of plants. Looking into the recycled plastics or recycled carbon, We can use plastics as such through the mechanical process, but we can also have the thermochemical processes where by heating we are producing different molecules which afterwards are turned into suitable monomers which further are used for the synthesizing new polymers. CO2 we can recover and then add with a renewable and electricity source produced hydrogen, combine them both through the chemical processes into different monomers which further can be used also as a polymers. And the third one option is, which is probably at the moment the most used, is to produce new bio-based materials using bio-based sources from nature, like different sugars, different oils from plants, also biogas as a source. We have also a lot of waste from the different bio-based industries, like for example paper and pulp industries producing lignin, and lignin can be further carbonized into production of the carbon, what I was mentioning earlier, which could be used directly as a additive or functional additive, but lignin can be also used as a base chemical for making new polymers. A lot of research is going on all those three renewable carbon source valorizations, and I believe that in future we have much more materials and much more different sources to choose from than we have at the moment. So here you see the few examples which could be used for the production of PCBs. So in this case we want to exchange the epoxy glass fiber PCB substrate for something bio-based, or at least some plastic which is recyclable. So on the left side you see the nanocellulose substrate. Additive manufacturing is applied to deposit the conductive path. Additive manufacturing actually is more advantageous method for that and more suitable for polymeric substrates, because it doesn't need chemicals which polymers usually can't withstand. In etching processes usually are the ones used in the conventional electronic production. Also the temperatures used for additive manufacturing are much lower in the subtractive manufacturing. On the right side you see also the silk screen printed circuit. It's printed on the PET, but it shows also the possibilities for the polymers to be used in a different way than it is before. There is the YouTube video, you can look into it, what the Molex company is suggesting to be used as a printed circuits. Fiber composites, as I mentioned earlier, when you exchange fiber or some part of polymer with the fiber, you have also much more bio-based and sustainable version. They are used in casings. Here are two examples. One of them is PLA and fiber used for production of casing of the loudspeakers. This is finished product, Genelec. You can look it if you want to from their website. There is also an American company who is producing the recycled plastic with the fibers, with the natural fibers, using some wood in the earbuds. All the product is recyclable, so afterwards when you can separate your electronic components from the casing, all the casing can be grinded and used again. So you can explore yourself new products in the market, and I am sure it's more of them are coming in the near future. Choosing bio-based material is one option. Bio-based materials usually are from renewable sources, and then they usually are virgin at the moment. There are not so many bio-based recycled materials in the market, and probably none, because the bio-based product itself, collect and recycle at the moment is not possible, unless you have access directly to some company who has it as a scrap. Otherwise, you would rely on the recycled plastics from the market, and the differences are presented here in the table. Usually, the quality problems coming with the recycled plastics are in smell. So in many cases, or in some cases, you have different smell. It depends what was the source of the recycled plastic. So before purchasing one, probably would be a good choice to test a small batch of it. You usually have the gray color of it because it's mix of the different types or different color of plastics in it. Quite often you have gray gloss, which is then difficult to manufacture further or to use in the next manufacturing steps. And then when you have gray gloss, they could be causing problems on your surface quality. And then one of the restrictions with the recycled plastic, it's actually the availability in the market. There are not many databases from where you can see directly the same property polymers. So it means that every company who is doing the recycling, they are selling probably their products already early enough at the developing stage, so you don't have necessarily easy access to the material. You have to make business-to-business connections already early in advance before you start even your product development. And then, because we have all the time different products in the market, so quality of the recycled plastic might vary somehow, and you have to take that into account when designing the product. So it's of course also the economical problems we have related to the complex supply chain, which is involving not only the direct supplier relationship. In some cases you need to have also access to those who are collecting the material and who are doing the shredding and who is doing the conversion of those recycled plastics into the product you could use. One of the advantages in the virgin materials is that usually you have very strong support for your technical requirements. So the supplier usually has a lot of information. It's usually placed in the MSDS or TDS, so-called, so technical sheets. While in recycled plastics, because of the changing materials, usually both MSDS and TDS are of the lower quality or not available at all. So when developing new product, you should rely more on your own knowledge and on the properties of the material you have been testing than on the material properties were provided by the supplier. There is also some price issues. In this case, recycled plastics probably are more advanced or have advantage because usually they are not following the oil price. They could have the costs lower than the virgin plastics. On the other hand, if we have very high quality and high grade material, the price would probably follow the price of the virgin material. And virgin material, because it's reliable very much on the oil price, you know the situation now, the price can go very high. So, and probably when the prices are going very high, also the products going very high, and the companies' profits are reduced because of the very fluctuating prices. In this slide you see the conclusion, actually how to choose all the materials you need and how to look up for the most sustainable options in them. So first of all, of course, you need to make the bill of the materials you are going to use in your process. Identify what they are, group them according to their function, and then estimate what kind of recycling options or what kind of end-of-use options for those materials you would have. As you remember from the eco-design lecture, we have two different cycles. We have the technical cycle and the biological cycle. Biological cycle mainly means that the materials will be biodegradable or compostable. And then technical cycle would mean that the materials would be recycled or some components from it would be recovered, dismantled, reused again. So after you have chosen those materials, you should contact your suppliers and ask for the different options they would have for those materials. Ask for MSDS, just to evaluate what kind of the substances you have in them. First of all is of course that you don't have substances which are not allowed according to all the legislation, but also to look that maybe they have more sustainable options, what are the conventional ones you usually is using. You should also screen for the different materials from the other different suppliers, and then evaluate if some materials can be replaced with the other materials. And depending on your LCA, if it's possible to get the data for them, you could choose the ones which you think are the most sustainable. The important is also to choose probably strategically which of the materials are the most important and which of the materials have the most of the input. Usually the highest volume materials has the most input, and it's we have to put most of the effort on finding replacements for them. Then when you decided what options you would go for, look for the different feedstock solutions. So instead of choosing the same material from maybe third countries, maybe you can find that material somewhere locally. You can look in the social aspects related to the material production. You can look into environmental aspects related to that, and then choose according to your own understanding. Or of course the best, if you have some data to compare, to choose the most sustainable option. Then when you have the materials, you of course design your new product or redesign your old product. You always have to think also that if your design is finally showing that you can't work with the materials you've chosen, you have to iterate again. Maybe you have to look for the new materials. In some cases it can be that you need to go back to the conventional materials, but then you are already gaining the knowledge and developing the knowledge base for the new materials, and where possible you could use those. And then finally you create the documentation for the end user, so that end user knows what to do with the product after its end use. And here, as a very final slide, I want to show you what are at the moment the top 10 electronic manufacturing trends or companies in the world, so that from this you could understand actually what are new developing trends and where the companies are going, what are the most promising startups. And you know, the startups quite often showing the way, and we will need to follow them in the future. So in here you see the additive manufacturing as one of the important parts. That means that we are going to more energy and renewable product efficient manufacturing processes. Then you have different organic electronics, especially in the solar panels, for example. The usually used metals are exchanged by organic materials. Then we have the different packaging systems. We have 3D printing, and we have the new technologies which are going to be important in the near future. So thank you all for listening. I hope those lessons gave you some idea what are the sustainable products and how to develop them. And I really hope that you are ready now by yourselves, go and explore further what is the future you want to be in. Thank you.